So this is the first question out of the two assignment given, and we have, if y is equals to x raised to power of e raised to power of x, we have to find the y dx. So y is equals to s e raised to power of s, such that we take the natural log of both sides, or the logarithm of both sides. And when you take the logarithm of both sides, you have ln y is equals to ln x e raised to power x. And don't forget that whenever you are integrating any whenever you are differentiating anything that has to do with y, you must always include dy dx. So when you differentiate ln y, you have 1 over y, but the dy dx must be inclusive. So 1 over y will be, when you differentiate ln y, you have 1 over y, and you must include the dy dx. Now similarly, on the right hand side, you have ln x e raised to power x. You bring down that e raised to power of x. Now you see that we have an exponential function multiplying a logarithmic function. So what you are going to do there is you are going to use product rule, because we have two different functions multiplying themselves. So you use the product rule to solve this. Now using the product rule, use f prime of g plus fg prime, which is the same thing as u dv dx plus v du dx. So when you use that, you differentiate e raised to power x is still the same thing as e raised to power x. You multiply it with ln x plus e raised to power x. When you differentiate ln x, you have 1 over x. So that is why we have our right hand side to be differentiated as the information given. So when you differentiate it, you make the y the subject of the formula, and we have our final answer to be y e raised to power x ln x plus 1 over x. Why are we having ln x plus 1 over x? We factorize out e raised to power of x, and we substitute back the value for y to be s e raised to power of x, and our final answer is given as x raised to power of e of x multiplied by e of x open bracket ln x plus 1 over x. So that's that for question number 1 on the assignment question. So the number 2 question goes thus. Number 2 question, we have ln x raised to power of m y raised to power of n equals to ln x plus y all raised to power of n plus n. So we have to show that the y ds is equals to y over x. So what we do is we apply simple laws of logarithm. So on applying simple laws of logarithm, we know that multiplication in logarithm is still the same thing as addition. So multiplication from law of logarithm, ln x raised to power of m times y raised to power of n is the same thing as ln x raised to power of m plus ln y raised to power of what? Of n. And similarly, we bring down the power of the m plus n at the right hand side down. So we have m plus n ln x plus y. Thereafter, we split it. We also bring down on the left hand side the power of x, that's m and n respectively. So we have m ln x plus n ln y. Now we differentiate. If we differentiate m ln x, you have m over x plus n ln y. And don't forget that ln y, anytime you differentiate ln y, you must always put the y dx. So we have m over x plus n over y dy dx. So similarly, for the right hand side, we have m plus n over x plus y plus m plus n over x plus y with respect to the y. Then we find the LCM. We collect like terms. After collecting like terms, we find the LCM of the like terms which we collected. The LCM of the left hand side is y open bracket x plus y. The LCM of the right hand side is x plus y multiplied by x. And when we simplify our LCM, we have nx minus my over y times x plus y. Similarly, nx minus my over x plus y times x. And since x plus y is common in the denominator for the left hand side and the right hand side, we cancel the two of them out. It cancels each other, so we are left with nx minus y minus my over y is equals to nx minus my over x. And also nx minus my, they are the same thing, so they cancel each other, so we are left with 1 over y is equals to 1 over x. Sorry, 1 over y dy dx equals to 1 over x. So we make dy dx the subject of the formula, and our final answer is dy dx equals to y over x. Thank you.